Hi everyone, this is the gas walkthrough for January 28. I'm Philip Newman, and today I'm solving Echo Lines by Bill Murphy. This is a new variant to gas. It's mostly new to me. I have tested this particular puzzle, but I hadn't seen it before that. But we have normal Sudoku rules, 1 to 9 in each row, column, and 3 by 3 box. Additionally, we have some lines in the grid, and along these lines we must have a sequence of digits that repeats. So what does that mean? Let's say we had a line down here, and I'm just going to kind of go like that. Along this line, we could have something like, let's say 1, 2, 4, and then repeat that, 1, 2, 4. Well, there's a 2, but you know what I mean. Let's make it a 7. 1, 7, 4, 1, 7, 4. The sequence doesn't have to be like a arithmetic sequence. They don't have to jump by the same amount. They don't have to be consecutive, nothing like that. It's just some set of numbers in a particular order, and that order and that set of numbers has to be repeated. So this would be valid for this line. We don't have to have 3 digits though. We could just have 2 digits. So maybe we have it's not going to work here, actually. Bad example, but let's remove that and make it like that. So now, for this line, we could have something like 9, 7, 9, 7, 9, 7, and that would be valid. We have a sequence of 2 digits repeated 3 times. So that's how that works. Hopefully that makes sense. We don't even have to have 2 digits. We could just have 1 digit repeated, as we will see momentarily. And we could have more than 3 digits. It's just, there has to be some sequence and it has to appear at least twice in the same order. So let's get started. Let's look at this line up here. Whatever the sequence is, it's going to have to contain a 3 and it's going to have to contain a 7. And there are only 4 cells, so if we're repeating 3 and 7 twice, that's already going to get us to 4 cells, so it must be 3, 7, 3, 7. And we're going to get the same sort of thing with this line. Now, this line is only 3 cells, so if it has a repeating sequence, we must have a multiple of 3 of that sequence. So the only way to do that is 3 5s. So our sequence is 1 digit repeated 3 times. We're going to have the same thing down here. I'll just mark this in blue for now. So we remember these are all going to have to be the same digit, and we'll figure out what that is in a little bit. Let's look at this line. This line has 4 different digits on it, and it's 8 cells. So those 4 digits have to appear in the sequence, and we must repeat it at least twice. Well, that's going to be 8 cells. So our first digit going this way is 1 something 4 something. So 1 3 4 2, and that is the order: 1 3 4 2 1 3 4 2. Now in this box, 8 can only go here, 7 can only go there, 9 can now go there as the last digit. 5 is going to have to go somewhere here, somewhere here. It would be tempting to just fill in 5 in these blue cells, but let's make sure we can prove it. 7's here somewhere. Where should I be looking? This is 1 3 6. The digits on this line are going to be odd. And we know we're going to have a sequence of 2 digits here for similar reasons. These are in the same box, so they can't be the same digit. There's at least 2 digits, and we can only repeat them twice because we only have 4 cells. And same up here. So we can think about what those digits could be. So on this line, we can't have 3, 7, 6, 1, or 5. We can't have 8 in this cell, or 7. And we can't have 4 or 2 in this cell. So the only thing for this to be is a 9. There's probably some more straightforward way to see that, but we'll go ahead and use it. Now this one has a little more flexibility. It can't be 4 or 5, and it can't be any of these digits. So it is 8 or... is it just 8? 8 or 2. Okay. So we'll fill that in. Here, I said these have to be odd, and here, these two are the same. So first digit, second digit, first digit, second digit. Can't be 5, 7, 3, or 1. So they have to be 9 as well. And then this digit can't be 3 or 7, and it can't be 5 there, so it's going to have to be 1. So that one is resolved. Alright, 3, 5, 7 here. That's still not resolved. 5's in one of these two. I feel like I'm missing something really obvious because I don't remember it taking quite this long when I tested it. Oh, let's figure out what this can be. So in this column, it can only be 2, 4, 5, 8, but this cell sees 8, 2, and 4, so it is the 5, like we might have suspected. So let's get rid of that, and we have enough 5s at this point, maybe, to do something more? No, not quite. So 5 here, 5 here, 5 here. Not resolved. 3, 7 here is resolved. So let's do that. The 3 now must go here. This is a 2, 6 pair. This is 2 or 5. Over here we need 7, 8, 9. I can already feel my voice starting to go. I have more of these to record. I don't know if that's happening today, but we'll see. 2, 4, 8 in these cells. Two and 4 have to go here somewhere. 4 has to go in one of these two cells. That should be more interesting. 2, 4, and 6 in this column. 1 is in one of these cells. 9 is in one of these. 7's in one of these. It's not quite getting there. What am I missing? 6 is in one of these. We have 3 and 7 here now, so 3 and 7 must go in these 3 cells, but now can't go in that one, so this is a 3, 7 pair. That's going to leave 1, 2, 4, 6, so that's 2 or 6. That's 1 or 6. 1, 2, or 4 there. 9 now must go there. That's been there for a while, since we have all of these 9s. 9's in one of these. 9's in one of these and these. Similar to the 5s. 5 now must go here, and that's going to resolve our other 5s and some other stuff. That's going to go 4 and 8. That makes that a 2, so we're finally finished with the variant 6 and 2. Alright, now 1, 2, 6 here, and 2 in the box. 7 here and 6. 3, 4, 8 here. These are 6, 7, and 9, and we should, if I can type, be able to do that. These are 1 and 9, which is resolved. 3, 4, 8, and then 2, 4, 8. Not resolved. Yes, resolved. Partly. The 2 can't go there, so 2 has to be there. And then 3 in one of these cells. The 9 looks up. and 4, 8, and 2 again. Not 2, 3. That can't be 3, so this is 3. And this can't be 4, so that is going to resolve those finally. 8 there. I think the purple is messing with me. I can't see this 2 unless I focus on it. This is 6, 1, 6, 1, 8, 1, and finally 4. That was quite a long solve, which is fun. You can kind of see what my thought process was there. So I hope you found that helpful. This is an interesting variant. I think in a non-gas you could do a lot with the fact that you don't know how long the sequence is going to be. You don't know how many times it's going to be repeated. So, like that 6-cell line we gave as an example could be 2 digits repeated 3 times or 3 digits repeated 2 times. So I think that could be interesting. Bill gave us a pretty simplified version of this, but it didn't resolve immediately. These were a little trickier to resolve. So, hope you enjoyed it. Let us know how you did in the comments, and I will see you next time.